Hi again, everybody, and welcome back. This example 510, is going to be our first practical application of the tension force. So what this is right here, this traction device, is a device that is used sometimes in hospitals to apply a pulling force or a tension force to a limb. In this case, it's a leg, with the purpose of kind of helping it to set. That is, if you break a bone, it helps you the bone set if you apply kind of a pulling force to it. I've never done it. I'm sure I've heard that it's not all that pleasant, but you have this kind of pulling force on the end of your foot for a long time. Now, what you could do is just sort of pick your leg up in the air and let a heavy weight hang from your leg, but that's not very comfortable either. And so what this does is it allows you to lie sideways, and you have a downward pulling force. Now, by the way, while we're at this right here, what is this pulling force going to be created by? It's going to be created by this hanging mass right here, right? And we'll just state right on at the outset that that is mg. That's the weight force of that. And that's creating all this tension in this rope right here, such that this rope at an angle is going to be creating an outward force in that direction, pulling on the person's leg. All right? That is 165 newtons. If you divide that in half, it's about maybe 40 pounds or something like that. All right? So we want to find out what mg has to be in order to create the appropriate amount of tension, which is 165 newtons. All right? Now, one thing to remember about ropes is that they create tension in two directions all along the length of the rope. All right? And if you have a rope bent around a pulley doesn't really do anything other than change the direction of the tension. All right, so what's happening right here, this person's leg, we're utilizing gravity, right? So gravity's acting straight down, but this person's leg is being pulled horizontally because the pulley is allowing this tension to be applied at angles to the person's leg. So I'm going to draw this as a dark brown. So this tension is pulling up like that on the person's leg, and the tension right here is pulling sort of downward at an angle, and both of these are at a 40-degree angle from the horizontal. All right, we want these two tensions to add up to 165 newtons. All right. Now, what is this tension? What is creating the tension in this rope? The tension is created by mass times gravity, mg. If there's no mass right here, then the rope is completely slack, and the person doesn't feel any pulling on the bottom of their leg to help their bone set that they had broken. Okay, so our assumption here is the tension is going to be mg. Okay, so this tension force is pulling up at a 40-degree angle, and this is pulling downwards at a 40-degree angle. Well, we don't care about the forces at an angle. We care about the force along the length of the person's leg. That is right on the horizontal right there. So this 165 Newton force, I'm going to erase, and I'm going to replace it with the x component of this tension force and the x component of this tension force. Again, if you have a pulley wrapped around or attached to the bottom of your foot and a rope wrapped around it, you have tension pulling two different ways from that pulley. So we actually have this force and this force acting on the bottom of the person's foot. All right, but like I said, the x component of that is what we care about. So tension in the x and tension in the x. We want this all to add up to 165 newtons. All right, we want it to add up to 165 newtons. Why does it have to equal that? Because that's what we're told, that it's got to be 165 Newton force pulling on the bottom of the person's foot. Okay? So we can say that tension, the x component of tension, plus the other x component of tension has to equal 165 newtons. All right? Well, what did we say the tension is? What's creating the tension? Oh, it's the weight force created by this mass right here, right? So why don't we take this, and first of all, we should, what we're going to wind up doing is substituting in mg for tension. All right, so these t's are going to become mg, so we can solve for the mass, m right here. But you know what, I realized we need to do one more step before we do that, and that is we need to write these x component of tensions out in a little more detail, right? What is the x component of those tensions? Well, that's going to be t times a cosine of 40 degrees, right? Cosine 40 degrees plus, do the same thing again, that full tension force T times a cosine of 40 degrees as well. Cosine 40 degrees. They all have to add up to 165 newtons. Okay? So, we're going to, in just a minute, we're going to substitute mg in for tension. So then that we can find out what the mass m is. All right, but before we do, let's factor out these t's. So instead of having two of them, we just have one. All right, does that make sense? So we're just going to pull both of these outside of a parentheses and put everything else inside the parentheses. So it's going to be t on the outside, and then what's going to go on the inside? Well, you're going to have cosine 40 plus cosine 40, right? That's 2 cosine 40 degrees, right? All has to add up to 165 newtons. Okay? So, again, what are we solving for? We're solving for this mass, m right here. We're going to solve for what that is so that it creates the right amount of tension, so that these two tensions at these 40-degree angles together add up to 165 newtons. All right? Well, now let's do the job of substituting in mg for tension, because the weight force is creating the tension right there. So mg times 2 cosine 40, right? 2 cosine 40 degrees equals 165 newtons. Well, if we're solving for m, solving for mass, then that means we're going to have to divide down the g. So divide, and that's going to come down here. And also the 2 cosine 40 is going to be divided down to the bottom as well. So that means we're going to have an equation for our mass m being equals 165 newtons divided by g. G is going to come down to the bottom right there. And also divided by 2 cosine 40 degrees. All right, let's punch in our values. I'm not going to rewrite it again because everything else is written in here and we know what g is. So I'm going to take, let's see, 165 and divided by 2 times 9.81 times cosine 40 degrees. What do we get? I get, it's going to round up, but it's going to be 11, I almost wrote newtons, sorry. 11 what? 11 kilograms, right? Kilograms is our unit of mass. And that's what the mass of this object has to be right here in order to create the appropriate amount of tension at these two 40-degree angles, to add up to 165 newtons. Okay, so that, like I said before, this is our first practical application of tension. Tension can do some interesting things, especially when you couple it with pulleys. But in this case, the tension is really being doubled right here because it's wrapped around a pulley attached to the person's foot. And the two tensions, the two x components of the tension is going to be adding up to 165. That tension all is created by that 11 kilogram that we just solved for mass being subject to gravity, so creating that weight force. All right? So thanks for following along on this one. If you have any questions, please let me know. But in the meantime, thanks again, and I'll see you on the next one.